We are going to talk about the compilation process in C++. What you're looking at here is the stepwise processes starting from the very top, starting with your C++ source code .cpp, feeding into the C++ preprocessing step, which is number one, which goes into step two, which is the compilation itself. The compilation then leads into what we call assembly, which then leads into the final step, the linkage. The processing itself doing compilation could be conceptualized into three processes, namely number one, the preprocessor, number two, and then number three, which is the linker. This is sort of the intermediaries. You can also think of the entire compilation process being two and three combined. The step in between two and three that involves assembly built into the compiler itself. Let's review this on a very high level. The first part, this is the preprocessing that takes in the included header files. This processing step produces what we call expanded source code. The outcome of your number one is another C++. It's just a lot more bloated with the header files included. This file is fed into your step number two and three. Step number two and three produces what's called an object file. This is where all of the symbols are compiled together and interpreted into a whole bunch of ones and zeros. As you know, that's what assembly does. All of the .o files, there's a whole bunch of them out there. It could have multiple .o files. These are what we call object code files. These object code files then get fed into what we call a linker, which is another software that produces the eventual executable. That's what you see here. Executable could be an exe file on Windows. It could also be a DMG files on Macintosh, or it could be a jar file if this is a library that you're trying to compile into. Jar has nothing to do with C++. I'm just saying, in general, executable files are like that. That could be executed on any machine. Let's dive right into each specific number one, preprocessor, number two, compilation that involves assembly, and then number three, which is linkage. Let's move on to the next page. The compilation of a C++ programs involve three steps. Step number one, the preprocessor takes a C++ source code file as your input, and it deals with all of the pound includes, pound define. So we'll get into this. Whenever you see pound include, pound define, especially pound include pulls additional files in. So these are typically what we call header files, or basically a file with all of the code declarations in it. For example, one of the pound include is IO string. That is a file declaration, a header file that has all of the input and output features or library declarations in it. Preprocessor takes all of these files, once found, include them in your actual code. If your pound includes all the way on top of your files, what you end up with is a pretty bloated file with all of the pound included libraries and declarations in it. The output of a preprocessor step is a pure C++ file without any preprocessor directives. The second part is a compilation of step two and three, which involves both the compilers and assembler, two and three. The compilation step is performed on each of the preprocessed files. If there are several of them, it will go through all of these files one at a time. On a pure C++ file, what this does is this object file, once compiled, it's actually the assembled files. The compiler takes the preprocessed file and compiles them into assembly code. This is the assembly process that happens very quickly. The assembler is responsible for converting code into a whole bunch of ones and zeros. So these are machine code on a lower level. After assembled, it's a whole bunch of symbols. The output of a compilation gives you an object file. Let's go into the last step, which is the linkage. The linker generates an executable on your behalf. Depends on how many object files you have. If you have a complicated program, you could have 10s and 20s or 30s of these object files. This object file, it's linked. This is where all of the symbols are found. Let's say if you have multiple object files, this linker, which is a software, it links all of the object files. The linker takes these symbols, basically assign them with correct addresses in memory. The entire executable, when generated with all of the symbols They're basically loaded in memory for executions. Without this linkage, things could happen. Compilation is a loaded term. It's a combination of this preprocessing step one in the previous diagram, compilation itself, which includes compilation plus assembly, and then linking. These three major steps constitute this what we call compilation process in C++. The last part, linking, generates an executable file. In Java, in C++, some of these executable files, they could be a library. For example, in Java, you can have a jar file. That jar file could be compiled into another jar file or program. C++ is the same thing too. You can create a library as an executable, but this executable is not runnable on your machine per se, but they are executable in the sense that they could be executed as a library, as a plugin by another C++ program. So that's what this executable means. Linker is a very important part of this process generating it. Sometimes we'll get compilation errors coming out of this stage. Sometimes we get linking errors out of this stage. Compilation errors typically happens when there is misspelled keywords, missing punctuations, and things like that. These are syntactical issues that comes out of the compilation stage. But linking is different. You could have multiple files. During linking, there's no possible way for you to find where the symbol is located. Perhaps you're missing another .o file somewhere. So linker, it's another source of issues that could happen during the compilation process. Most of the time, your integrated development environment or IDE will give you some hint in the errors produced. If the error says compilation errors, then you know what it is. Linkage error is also pretty explicit. Sometimes you'll see something to the effect of this particular symbol cannot be found. And then you look at the symbol, that's the variable I declared. If that variable was declared as an extern, but it wasn't defined anywhere else, so you get what's called a linkage error. You get into this compilation errors a lot. But this is all static as in non-runtime. If you look into the chapters, there is a lot more descriptions about what each of these steps is doing. This is compilation processes in C++.